Hello, my name is Cristian Orellana and I am here to explain to you about my thesis project that, as you can see here, it is a solar generator attached to a tracker. The motivation behind this project is that nowadays it is required to develop new strategies to get electrical energy, and even though the sun is a renewable energy source, it can only be fully exploited if the solar rays are caught perpendicularly by the photovoltaic panel. And that's the purpose of this project, to follow the sun path during the day. It can be achieved with the help of an artificial intelligence algorithm that receives as inputs the weather conditions measured by some sensors and returning the corresponding inclination angle at a certain hour. Then, this information is stored in a web server for the user to monitor the solar panel status from any part of the world. Let's see how does this work. First, here are the electrical components of this project. It is important to know its function to understand the scope of the prototype. Raspberry Pi 3B Plus is the microcomputer that controls the entire system. This device determines the correct angle with the help of its loaded neural network, algorithm developed in Python using TensorFlow Keras. Additionally, this microcontroller uploads the data of the sensors to the server via an AP configuration. However, its limitation is the analog ports, so an auxiliary port with serial communication is required. There is where ESP32 enters. It is a microcontroller with digital and analog pins and serial communication. All these sensors are connected to it, and then, depending on the request of Raspberry, it sends the desired measure, such as, for instance, temperature or radiation. Additionally, this manages the inclination of the panel by reading an analog encoder and sending signals to the motor driver that will move the panel. Now it's time to see the involved sensors. Temperature, humidity, radiance, atmospheric pressure, voltage and current sensors are used, and an encoder too. All of them are in charge of measuring every weather condition and panel status. Then, the chosen motor for this project is a Wiper motor, able to rotate the solar panel. It is one of 5 amperes, 12 volts and 60 watts, enough for this project. Evidently, this is controlled by an H-bridge. On the other hand, there are 9 line batteries connected in a 3x3 matrix and their respective charger. This charger is connected to a voltage regulator because the panel provides almost 3 volts and it is only adapted for 12 volts. Finally, the limit switches establish the ends of the rotation of the solar panel. The movement is stopped when they are pressed. The solar panel must not rotate more than those limits for precaution. These videos show their functionality. As you can see here, were measures. These measures are sent to the Raspberry, where the neural network predicts the corresponding angle and returns it to the ESP32 for the movement. The panel rotates, and after a while, the voltage and current are measured. This procedure repeats during all day, and that behavior can be seen in the web monitor. To check them, you must access to this link. There, the credentials are mantenimiento and MEC.2K22. Then select the option Monitorear Panel, where you can see the history of the measures and the prediction of the angles. As it can be seen, the azimuth and elevation angles that describe the sun position during the day are also predicted. Here is a video that was recorded during all day, and the graphs generated during that period of time. Finally, I want to thank Senase for the sponsorship of this project. Without their help, this will never proceed. Also, I want to thank Cristina Escuyo, my tutor. Her feedback was very helpful for me during the development of this prototype. Additionally, I want to thank my parents. They were a grateful support for me during this time. And I want to thank you. This video would not have a purpose without your attention. Thank you a lot. I hope you have enjoyed this explanation a lot. And that's all for today. See you in the next time.